New for Motion in 2011 is the ability to apply a motor to a pathmate. When we define a pathmate, we just use the distance along a path or percentage distance, and then we can drive that value using the motor. It's a very straightforward process. When you go to the motor option, you'll see you now have the pathmate option, and just select the mate that you want to drive. In this instance, what we've done is we've applied a motor to every one of the ribs in this conveyor belt, so that we can then drive it around like a conveyor. And it's useful for other applications as well, such as overhead crane systems, to emulate chain type conveyors, or even things like roller coasters. So it's a very powerful tool, and it gets around the limitation of not being able to enforce a motor in more than one direction. So let's take a look at how this works. In this case, just to quickly show you, all we're doing is we're driving these ribs at a fixed speed representing the conveyor speed. But obviously it would work with event-based simulation as well, so you can do event-based motion. All we have set up here is some contact between this barrel and the belts, as well as the outer frame. So it just takes a second to rebuild, and away we go. And the reason it works so quickly is because it's all kinematic aside from the contact. So there's not that much overhead to actually using pathmate motors. So it will help you do things a lot more efficiently. You can see in here we've actually got a little bit of friction, so you can see the barrels spin around as it rolls along the conveyor system. And there we go. So we can just play that real time. So you can see, very nice looking. And we can take that a step further by providing a whole series of barrels and see what that overall resulting motion looks like. So again, it's going to be great for machine designers or people who want to study the operation of conveyors, cranes, roller coasters, whatever. It's a great new enhancement to the motors in 2011. Another area of improvement in 2011 is with how we define movement of our systems, whether it's through motions or forces. And that's a new and improved motion function builder. In this case, what we're doing is we've got a packaging system. We're going to do a pick and place operation to put these shrink wrap towels into the cardboard boxes. What we're going to do is just focus on the timing of the move over. We want to shift the package over once it's raised from 0.5 to 1.5 seconds. We've already got a function set up, but let's look at how we go about creating one of those. We have our built-in system of functions, such as constant speed, distance, oscillating, and so on. But we now have the ability to create our own custom functions, as you can see here. And you can either save those or load them from file, and we can create new ones. So you can see we have our regular types, such as bringing in data point functions. The function expression has been greatly improved, where we now have immediate access to all of the available functions in the list over here. So if you want to use any of them, just select the function and then fill in the blanks, and it will actually graph those for you as well. We also see access to the variables and constants. Something new in 2011 is support for cycle angles. So if you're in the machine design business and you've got a cycle time for your machine, you can actually set it up and work out everything based on a cycle time, and just adjust the cycle time for everything to scale the timing and movement of the parts. Very powerful tool for machine builders. Alright, but the most important one we want to talk about is segments. And really the changes that have come have really been driven by customers, and with that the way they want to define functions, which is to build up ramps, dwells, and so on. So let's take a look at how we do our transition across. Like I said, so we want to push it over from 0.5 to 1.5, hold it over at the other side from 1.5 to 2.5 seconds, and then bring it back from 2.5 to 3.5 seconds. So the first step to do that is from 0 to 0.5 seconds, keep it at 0. And again, we've got different interpolation options here, which again customer driven based on how many functions they typically use. But from 0.5 to 1.5 seconds, we want to move it across. So we're going to move the motor 190 millimeters. And again, we'll just set our interpolation. And this is where you can see the value of seeing the velocity, acceleration, and jerk profiles. And from 1.5 to 2.5, we're going to hold it there. So this is the dwell. And then finally, from 2.5 to 3.5, we're going to return back to 0. And then from 3.5 to 4 seconds, which is the end time, we're just going to hold it down there. And again, we can set, as we said before, we see the velocity, acceleration, and jerk profiles for using that. And we can type in the name here, and like I said, we can either save or load it from a graph. You can control if you just want to see the displacement function. And you can see zoom to fit, you can zoom to the area of the graph, and so on. Alright, so let's take a look at how that works. Just click on calculate. So it picks it up and then it moves it across. And I've added a few mate controls to turn some mates off so it'll actually drop it in the box. So this also will work well with event-based systems as well, because you can build up some very nice functions. And we can see here, we'll just fit the graph. You can see here's where we turn off the mates that hold the product. Now if we combine this approach with the PathMate motor which we just saw, we can do the whole system. So we can index the conveyors, pick up the product, move it across, drop it, and so on, and repeat the cycle. So we really have improved the capabilities in 2011 for machine builders to get their jobs done, make it easier to do things, reuse information, and ensure the machines are going to work the first time.